I closed it off. I got up towards noon Monday. I was just writing my dissertation. I had no classes, so I had my coffee. I reopened it. I said, let me run this thing again. I run it. The damn thing works. I have changed nothing. The ghost in the machine. So that sort of stuff works. Now, the way I would interpret PE then is if, and that's a big if earnings were to remain at their current level per year, then PE ratio tells me how long it would take me to recover my investment. Let's say PE is 10. So I paid, price is 100 and EPS is 10. So it's going to take me 10 years to recover my investment. After that, I'm going to start making money. Now, that 10 may or may not be a reasonable number. You know, that depends on a lot of things. What's your discount factor? But we're not going to worry about it. But if I can get away with that big if, that EPS is going to remain constant, I can then use something like PE to make comparisons across firms and to make trade decisions. I'll give you an example. You know, those two companies I have, let's go to financeyahoo.com. Let's look at NVIDIA. And I'm going to go to statistics. I'm going to use something called forward PE. It's price divided by earnings expected next year. It's always a good idea to look forward. That says 41.67. So if we were to believe that NVIDIA's earnings are going to remain constant, it's going to take me almost 42 years to recover my investment. Then I'm going to make some money. Obviously, that's a very high number, right? On the other hand, let's look at MU. I don't know why it's down that much today. Nothing changed. It's 10.5. So if you could assume that earnings are going to remain the same, today it is obvious. I have to buy Micron and short NVIDIA. Short means you sell stocks that you don't own. You still do the same thing. You're buying high, you're buying low and selling high, hopefully. But the order of buying and selling is different. When you short, you sell first, then you hope it's going to go down and buy. No, you're going to think there may be a reason people are allowing NVIDIA to have forward PE of 41, because the big assumption under the PE is those earnings per share are going to remain constant, which we know they're not going to be. So let's kind of figure out what people are thinking. Let's look at the analysis. For example, I mean, this year, analysts are expecting that Micron is going to make $1.22 per share. Next year, they're expecting $9.41. But on the other hand, over the next 5 years, 5 years after that next year, they actually expect negative growth. Whether or not that's going to be the case, that's a different story. Let's look at what they expect from NVIDIA. I'm just going to look at the growth numbers here. Next year, they expect earnings to go up by about 41%. And the 5 years after that, on average, they expect a growth rate of over 50%. Do you know what growth rate of 50% over 5 years mean? Your earnings are going to be octupling, go up by 8 times. That's the difference. Okay. Again, looking at certain stuff, maybe Micron is still cheaper, but your criteria is not the PE ratio. So whenever you put on a financial ratio, you have to know how it should be interpreted, what's low, what's high, and what are the drawbacks to it. I mean, just like, scientific models, all scientific models are approximations to reality. Okay. There is no perfect scientific model. Even physics, with all the mathematics they know, there is no perfect explanation of everything. There is no theory of everything. Even if you could combine, for example, quantum mechanics with general relativity, the so-called quantum gravity models, even that cannot explain the beginning of the universe. What was there before Big Bang, if there was a Big Bang? You can explain everything until the you know the first microsecond, but before that, who knows? But all theories are useful within certain contexts. Until 1500s, there were models of planetary motion. Some of them are Earth-centric, some of them are sun-centric, the heliocentric. But they all knew that those 5 planets they knew about, okay? They knew about Mercury, Venus, Mars, Jupiter, and Saturn. In fact, the reason there is only 7 days in a week, we also have obviously sun and the moon. Those were the 7 wonders. These were the stars that actually moved periodically. If we had discovered Uranus and Neptune, the week would have been 9 days, because those were celestial objects. In fact, in many cultures, they're named after gods. I mean, think about the names of the weekdays in English. Sunday is obvious, Monday is obvious. In fact, in many languages, for example, in German, it's Sonntag, Montag. In Spanish, what is it? What was it? What was Sunday in Spanish? Yeah. Huh? Domingo. Domingo means kind of God, right? And what is Monday? Luni? Lunes. So moon. But the others are kind of named after in English language, at least. For example, Tuesday. You know where that comes from? Comes from? Remember, the modern English language is a combination of the Old English of the Anglo-Saxons and the Norse. You know, the Danes and the Norwegians spent a lot of time in England, and so they were named after Norse gods. So it's Tew. Tew is one of the Norse gods. It's Tuesday. Wednesday actually originally was Odin's Day, but over time, Odin's Day becomes Wednesday. Thursday, you have to know that. It's Thursday. Friday, you're thinking of a free day? No, it was originally Prayer's Day. Okay. Prayer is one of the Norse gods. Saturday is named after Saturn, but Saturn was a god in Roman times, remember? And Sunday. In some other languages, uh, for example, in Welsh, Thursday is Yai, which means Jupiter. In Latin languages, they're more based on the planets. What is Wednesday in Spanish? Mercredi? Huh? Miércoles. Oh, Mercredi is in French. But that's after Mercury. And it goes on and on. The original theories of planetary motion were good enough. They were kind of convoluted, but the so-called Ptolemaic model uh, it was able to explain the planetary motion. Over time, there were issues, especially with the motion of Mercury, because it's so close to the sun. The Kepler's heliocentric model, which basically said, all the moves are going to be elliptical around sun, that helped quite a bit. Then Newton came along, and he said, it's because there's something called gravity. He didn't know what gravity was, but he had an equation that predicted how planets were going to move. And that worked fine, especially if you're going to plot a orbit for something like Jupiter or Mars. But it had slight issues in Mercury. Any of you guys have heard something called Mercury being in retrograde? That's a very common thing in astrology. Okay, you don't want to do things when Mercury is in retrograde, supposedly. And Newton's theory could not explain that. But does that mean that Newton's theory was not a useful theory? It was. If all you wanted to predict was, where Mars was going to be 20 years from today, it does that to a very big accuracy. For example, recently we sent a little ship to an asteroid. Okay, it actually hit the asteroid that was orbiting around another asteroid. The idea was to see, can we see with that impact, can we change the orbit of that asteroid? If we could, then we learn from that. If there's an asteroid that is coming too close to Earth, we can do something like that and change the orbit.